Welcome to the 3Dflow Academy. In this tutorial, we'll see how to configure camera groups in 3ds Zephyr through an underwater case study. You can follow along in Zephyr by downloading the dataset captured with a stereo camera system mounted on a Deep Trekker ROV from the link in the video description. Before we begin, the images from each camera must be saved in separate directories, making sure each folder contains the same number of files. This structure allows Zephyr to automatically identify the camera groups and ensure correct matching between them. By default, the software will assign reference status to the first folder alphabetically, whilst additional folders will be defined as groups. However, if needed, you can manually reassign reference status to a group of your choice. The first procedure when setting up camera groups is to use distance parameters. From the File menu, click New Project to open the project wizard. Then, enable the Setup Multi-Camera Groups checkbox and click Next to continue. Now we import the photos. The idea here is that the images from different cameras are organized into separate folders, for example, left and right, inside a parent folder that we'll name Images. Once the images are loaded, Zephyr automatically recognizes the different folders and asks whether you want to link them together. Here it's essential to answer yes, so Zephyr links the folders and automatically creates the camera groups. In the Multi-Camera Groups window, you can see the groups that were created, a reference and a group 1. In our case, 2 cameras with the same number of images. Now we can set the constraint type between the group and the reference. And from the Type menu, we choose Distance plus Rotation. With this mode, we're not telling Zephyr which direction the second camera is relative to the reference. Instead, we're enforcing a fixed distance between the camera centers. Next, we enter the distance in meters, which in this specific case corresponds to 0.1193 meters. Right below that, there's D accuracy, which defines the constraint accuracy and indicates how much Zephyr should trust the specified distance. Low values make the constraint tighter, whilst high values allow for more flexibility. Once the constraint is set, we continue by clicking Next to move forward in the workflow. If we know not only the distance, but the actual relative position between the cameras XYZ and their rotations, then it's possible to use the translation plus rotation as the relationship type. This is the second procedure to set up camera groups. Instead of entering them manually, it's possible to load the translation parameters directly from a file by clicking Load from XML. Just select the file with the rig's external parameters, and once imported, the translation and rotation fields will be filled in automatically, along with their respective accuracies. The same rules apply here as well. T accuracy and R accuracy control how tight the constraints are. If the parameters come from a reliable calibration, we can use smaller accuracy values. If they're rough measurements, it's better to keep them flexible. In the camera calibration step, Zephyr uses auto calibration by default, but in underwater multi-camera setups, it's often advantageous to provide internal parameters such as focal length, principal point, and distortion. This can improve orientation and consistency across the cameras. To do this, simply select a calibration file associated with Group 1 and click the Modify Calibration button. If it's an external file in .text or .xml format, you can click Import Parameters from File. In this example, we choose the calibration file for the left camera, and after importing it, we check that the focal length and distortion values have been entered correctly. To confirm, click the Apply button. Repeat the same step for the other group. Switch to Group 2 and assign the calibration file for the right camera. Confirm again with the Apply button. Now the project includes both the multi-camera constraints, the external parameters, and the calibrations, the internal parameters. We can proceed to orientation. Once camera orientation is complete, we can inspect the multi-camera groups directly from the dedicated viewer located in Tools, Workspace, Camera Groups. In this window we can see a cluster with reference and group 1, and we can select the group we are interested in. Below there are two key tabs, Initial and Final. Initial shows the constraints as they were set at the beginning, either manually or from file, and Final shows the resulting parameters after optimization during alignment. It's worth pointing out that even if a distance constraint is set at the beginning, Zephyr's Final tab can report the XYZ translation parameters and the relative rotations between the cameras. Finally, we can export the initial constraints or the final parameters at the end of the process using the Export Initial and Export Final buttons, respectively. Saving this data to an XML file will allow us to reuse the relationships between the cameras in further tests, significantly speeding up the setup of image groups. We've completed the workflow dedicated to the multi-camera setup in Zephyr for underwater scenarios. If you have any questions, feel free to contact 3Dflow technical support at support@3dflow.net.